Hello, welcome to this Matlab video tutorial. The name of this software, Matlab, is an abbreviation for Matrix Laboratory, and this is because while other programming languages mostly work with numbers one at a time, Matlab is designed to operate on whole matrices. So all Matlab variables are matrices. Even a scalar is treated like a matrix. So Matlab is not an algebraic manipulator as Maple or Mathematica. Instead, it is a powerful numerical computing environment. So when you start Matlab, the desktop appears in its default layout, and we can see different panels. This panel is the current folder where you can access your files. Then the most important one is the command window, where you can enter commands indicated here by the prompt. Then you have the workspace panel, where you can see the variables you already defined, and the command history panel, where you can see the previously introduced commands in the command window. So it's important that each time you start Matlab, you verify which is your current folder. Now we are working here in this folder, and it's very important that each time you start the software, you verify that you are working in the folder where you have your Matlab files. Okay, now to start, you can use Matlab as a scientific calculator. So, for example, I can introduce something like this. 2 plus 3 times 5 minus 9 over 7. Of course, Matlab knows that first products and quotients must be computed, and then the add and the subtraction operations. So, for example, if I introduce this with parentheses, the result, of course, is going to be different. I can also introduce variables, so I can define a variable called a and assign to it the value 1. Then it will appear in the workspace the name of the variable and its associated value. I can define another variable called b equals 2 times a, and then I can write a semicolon here, and that will suppress the output in the command window, but the command is executed, and I can see that because the b variable appeared in the workspace and it has an associated value of 2. We can also define mathematical functions. So, for example, I can define function f, writing f equals add, and between parentheses, the name of the variable, x, for example. And then I will define the function. Let's say I define the function x plus 8. Now, in the workspace, I can see that a different symbol here appeared. F is a function defined like this. And now I can evaluate the function at different points, maybe at point 1 or at point 3. So it's very easy to evaluate the function at different points. So let's do a very brief exercise. Up to now, we know how to define variables, we know how to define and evaluate functions. So let's do this exercise. Let's define a variable a equals 5, and then define the functions sine of x squared plus x plus 1. Then we will compute f of a and f of minus a. That's quite simple. We define a equals 5. So now variable a changed its value to 5. And then we will define this function f equals add, between parentheses, the name of the variable x, and then the function sine of x squared plus x plus 1. Now we can evaluate this function at point A. That means I will evaluate the function f at point 5. And I can also evaluate the function at -5, at -a. Now, if I want to clear the command window, I can use the command clc. This will clear the screen, but not the workspace. So still I have these variables already defined. For example, if I want to know what's the value of a, I can write it in the command window and it will prompt out its value. Okay, so already the variables are already there. So CLC only clears the screen. If I want to remove the variables, then I will use the command clear all. This will remove the variables that were defined. Okay, so let's move now to how to use the help. One way is to open the help environment here. That's very useful. Another way is to use the help command. I can write, for example, help and sqrt, and this will prompt out how to use the command sqrt. This will compute the square root of a number. So for example, I can compute the square root of 2, and I will see the result here. Now you can see that there are only 4 decimals here. If I want to see all the decimals that Matlab uses to compute, I will use the command format long. Okay, when I write format long, from now on, when I write a command, the result will appear with all the decimals that Matlab is using to compute. Now, it's important to know that you can use the up and down arrow keys to see the previous commands that you entered. Okay, this can be very useful. And for example, if I want to use format short, and again I want to compute the square root of 2, I will just use the up key to navigate to square root of 2 and then press enter. Okay, now we can also define matrices and arrays. First thing, let's say we want to create an array which is just a single row. Okay, to do that, I will call this vector v, and we will use the square brackets. Square brackets are used to define matrices and arrays. If this is a row vector, I will just introduce the numbers separated by spaces or commas. It will be exactly the same to write this. It's exactly the same as using commas. This is a row vector. If I want a column vector, then I will use semicolon to tell Matlab that this goes into a new line. Okay, so in this way we get a column vector. Now if I want to create a matrix, it's simple because it's just a combination of row and column vectors. So if I want to define a whole matrix, I will call it capital A. I will just introduce first row first, then semicolon, and I will introduce the second row, and semicolon, and maybe a third row, and then I will write closing the square brackets, and I will define the matrix. Okay? So now we know how to define matrices and vectors, but maybe we want to define a long vector. Let's say I want to define a vector like this one, a vector that starts at 1, 2, 3, and then maybe it has 1,000 positions. Yeah? How can I define this vector in Matlab? This can be done using the colon command. This colon command is used like this. I will write the start point, the step I want to use, and the end value. So let me do that. For example, I want to define this u vector. The starting value is 1. The step I want to use is 1 because from 1 to 2, I just want to add 1. From 2 to 3, it's just 1 step. And the final value is 1000, okay? So if I do that and I press Enter, you will see that the 1000 components vector is defined. Of course, if I use the up arrow key, and I write a semicolon, is a better idea to see all this in the common window. So I already defined this u vector. We can see here it has 1000 components, okay? Of course, I can define a vector that starts at 1, but maybe the step is different. Maybe I want to add 2 each time, yeah? So for example, if I define this vector, let's say up to 11, then you can see that we defined a vector that starts at 1, adds 2 at each step, and the final value is 11. You can also use this step using a negative value. So you can, for example, start at 11, subtract 2, and the final value to be 1. That's also possible, okay? So using the colon command, you can define vectors that are defined using a fixed step. If the step value is 1, you can not specify the step because the default value is 1. So if you just write this, it assumes that the default step that you want to use is 1, okay? Now, we know how to define vectors, how to define matrices, but now we need to know how to access, how to read the values that are stored in a matrix. The way to do that is to use the parentheses. So when we define a matrix, we use the square brackets, but when we want to read, to access, for example, matrix A is already defined, and I want to know which values store at the first row, first column of the matrix, I will write this. I will use parentheses. First position indicates the row. Second position after the comma indicates the column. So first row, first column, the value 1 was stored there. Yeah, we can see it better. You can see here the matrix A. Now if I want to access what is in the second row, second column, I will just write second row, second column, and I access this value 5 that was stored there. Sometimes I want to access a whole row of a matrix. To do that, I will use the colon command. For example, if I write this, I'm telling Matlab I want to access all rows, but only the first column. You can see there, the result is only the first column of matrix A, but all the rows of the first column. Yeah? We can access first row, but all the columns of the matrix, for example. The result of this should be the first row of this matrix. That's what we get, okay? For example, sometimes we want to access just a sub-matrix. Let's say I want to access the second and third rows and only the second and third columns of this matrix. The way to do that is to write here. I want to access second and 3 rows. I want to access second and 3 columns. So this way I get this 2 by 2 submatrix of matrix A. So to summarize, in order to define matrices, I use the square bracket. In order to read a matrix, to access the values, we use the parentheses. Now let's do an example here. Let's define following matrices and let's do some operations. Let's define matrix M to be 1, 2, 3, 4. And let's define matrix N to be 0, 1, minus 1, 0. And let's do some operations with these two matrices, okay? So in order to define matrix M in Matlab, sorry, this should be a semicolon, okay? And in order to define matrix N, we do this. Now I can do operations. I can add these two matrices, of course. Sorry, M plus N. They are 2 by 2 matrices, so of course I can add them just using the add operator. And I can also multiply them just using the multiplication operator. This will perform the standard matrix multiplication, so it computes the inner products between rows and columns, just using the product operator, okay? Of course, the matrix dimensions must agree. If I take matrix A, which is a 3 by 3 matrix, and if I try to multiply A times N, then an error will appear, and it says matrix dimensions must agree. And of course, if A is 3 by 3 and N is a 2 by 2 matrix, they don't agree, okay? Another important thing to know is that we can use the component-wise multiplication operation. So let's say, for example, I want to multiply N times N times N, but not the standard matrix multiplication, but I want to multiply 0 times 0 and store it in the same place, 1 times 1, store in the same place, minus 1 times minus 1, store in the same position, 0 times 0 and store in the same position. So this is called component-wise multiplication. The way to do this is to write a dot before the product sign, okay? So, for example, I can do M times N. This would be the standard multiplication. But if I do M dot product N, this is the component-wise multiplication, okay? Of course, if I have a vector V, like this one, I cannot multiply V times V, because dimensions doesn't agree. What I can do is to multiply the transpose of V times V. Note that the transpose of V is computed using the apostrophe, okay? Oh, sorry. So V transpose times V can be computed. V transpose is a row vector, V is a column vector, so dimensions agree. That's all I wanted to cover for the first session. Remember to review this session before moving to the second session. See you there. Bye-bye.